Welcome back. In our previous tutorial, we talked about reading bibliometric or biomedical literature data in R. What you need to do is, if you read it, if you search your biomedical literature in PubMed or Web of Science or Scopus or whatever database, what you need to do is you need to export your references in whatever format, maybe in RIS or EndNote or something, or from there you can also convert it to BibTeX, and then once you have the BibTeX form, you can read it in R. So in my previous tutorial, if you remember, we loaded a package like Bibliometrics package for doing some bibliometric analysis to have an overview of keyword, the author co-occurrence, the author keyword co-occurrence, citation data. I mean, in this tutorial, I will not talk about citations, but you can also, especially if you use Web of Science, because you can also extract citation data. So you can do citation analysis, something like which of the articles are most cited, and impact factor calculations, and the like. You can do lots of things with bibliometric analysis. So if you remember, we loaded this package. I will just simply load them again, and the link is the link that I drop below my previous tutorial. I can also show you here. This is the link of my all my BibTeX files. So it describes the author name, the book title, the DOI, and ISSN, and all these different forms. I mean, you can say all this is just what the BibTeX reference file contains. So you have the author, and the like, and so on. So I have about 600 references. All of them are about COVID. So we will deeply look into the contents of these references, and we will do some text analysis. But before that, we can revise what we did last time. So what you need to do to read that reference is you just need to copy this. I already dropped it in my previous tutorial, and then once you have it, if you already have your package, you can take the URL, and then you can read it. To read it, what you need is convert to DF, and then you have the URL, or you can drop the whole link here in quotation marks, and then you describe the database source. The default, as I said, is ISI, and the format is BibTeX because the file is in BibTeX. But you can also read other file types like plain text or something. If you, let's say, if you save your bibliometric, your BibTeX file or the reference file in plain text format. So you can also read plain text files, but I would prefer to have it in BibTeX. So now I will read it with this BibTeX file into a data frame. So a data frame is something like the observations as written in rows, and all the columns contain the variable names. So you see, if you remember, these guys, this BibTeX is written in this form. So it's, you see the author is this, and the book title, and this is how it's written in BibTeX. But you want to convert this in a data frame type, which you can see the observations in row and the variables in column, which will be easier for you to do some data manipulation in R. So converting this BibTeX file in data frame is the first and most important step to do. So to do that, we already have bibliometrics package. We can use convert to DF. It will take a little bit of time, so it will go through each and then it will read the references. So now it's already done, but depending on the amount of references or observations you have, then it may take a little while. It also has a bibliometrics package. It also has duplicate detection, like if you let's say if you extract references in let's say in PubMed or and then another one in Web of Science, maybe in Scopus or any other database, and then you collect all of them. So you read one file, another one here, another one there, and then you combine all of them, and then you can exclude the duplicates. The duplicate exclusion is based on DOI and title matching. So this guy, he writes a function to match each of, let's say, these ones. It goes through each article, and then it matches the titles and the DOI. So if there is any kind of 2 or more titles that have matching or exactly similar DOI, then the bibliometric package will consider them as a duplicate, and it will remove it. Yeah, I found it is interesting. Instead of doing duplicate deduplication in notes or maybe you know, in Mendeley or any other references in database, I very much prefer to do it using this bibliometric package because it's more accurate. But the other ones, they are because this is based on, you know, NLP, this natural language processing. So it's so sometimes, you know, you may write things like COVID, for example. If you write COVID like this, COVID, or if you write it COVID like this, so it's different because it's in EndNote. This will not be detected, may not be detected, you know, or it may be like COVID-19. One may write COVID-19 and the other one may write COVID-19 like this. So if you the article is about this, then EndNote may not, or EndNote or Mendeley may see these terms are different. But in this case, before deduplication, what it does is it changes all these into small letters. So then the case of the, you know, whether it's in caps or in small, it doesn't matter. So it will not matter in so when it's deduplication. Also, it will you know, it will remove the symbols. So it's based on, we will see that in our text mining, how you remove symbols and numbers and whatever kind of number, I mean symbol you would like to remove. So it's because of that that's more accurate. I found it more accurate to find to deduplicate. Then what we did last time, once we read, is we did some quick bibliometric analysis. So you use this biblio analysis, and then you define the data, which we already defined, and then the separator, because it's how it's separated in our bibtext file. Then you give it the options, widths, how many references that you would like to look at, and then you put it in summary, like it creates objects. The objects are the results, and in 10, and yeah, this is you can also look at from the bibliometrics package tutorial. So we have seen these are the top journals that are that really published a lot of topic, a lot of COVID articles. And the first one is like emerging microbes and infections, because when it's extracting the name of the journal, there is a little bit of change. You see there must be some kind of a non-alpha numeric symbol, probably that's why it appears like this. And it also shows some top-cited articles, but this is I would not rely on this result because I haven't extracted citation. So if you see, it's all there 0. That's why, because you know, I didn't extract. But if you extract it in Web of Science or something, if you are really into bibliometric analysis, like if you would like to look at the literature, let's say in COVID-19 for the past, I don't know, 2 years or something, then you may use you know, Web of Science and look at all the citation metrics. And these are some of the authors that were really prolific in publishing COVID-related topic. But this is just a very short span. So because I didn't I didn't search for a long period of time. It was only about 6 months or something. So you may see, if you do it yourself, so you may see these numbers may differ. And also there are some some titles with no author names. That's why it's NA. That's why it's counting it as 3. So it has probably freak more than any of the others. Yeah, well, that's it. How you read and do a quick bibliometric analysis, and probably let's see if there is any other plot. We haven't done any plot. So if you look at the COVID-19 database, once we read it, we may see some of the variable names, how they are defined. So this is the this identifier, like the row name. So it's like the first author and the year. This AU is author, and then the DE is keyword, like author supplied keywords. AB means abstract, and BO, I'm not really sure with that, but I have a screenshot of whatever that may mean. So AU is authors. This is actually from the Bibliometrics package. It's just I just screenshot, and you have author full name, title, and source. That's the name of journal actually, and the document type. Maybe it's a journal article or book or something. That's a document type. D is author keyword. These are author supplied keywords, and sometimes you may have like ID, like PubMed ID, for example, or in terms of web of science, there may be web of science machine learning algorithm. I don't know, some kind of ID. But you can also, I think it's in PubMed, this is probably PubMed ID. And you have abstract. That's what we are really interested in doing our analysis in our text mining. And corresponding authors affiliation, cited references. If you are doing really real citation analysis, then this data is important. Then you have total citations. Yeah, when you extract your references, once you complete your research, you extract I don't know, 1,000 or 2,000 references, and you make sure to extract this data. Otherwise, you cannot actually do citation. I mean bibliometric analysis or citation analysis. And DOI is direct object identifier. So every article, when they publish, they get this ID. It's a unique ID for each article. Yeah, so this could be very important, especially if you are doing deduplication or something. But the problem is DOI is introduced very recently, actually in the I don't know, 1998 or 1997. I'm not exactly sure, but it's just before, few years before early 2000. So that's what DOI is. So if you would like to do like a matching or something, title and like observation matching one with the other, if you want to do like a duplicate search or something, this may be important, but unfortunately you would have to select only rows with DOI, because you may have a lot of missing values. You may not have all of the observations with DOI, because this is a relatively newly introduced identifier for many journals. Many journals these days, they have whatever they have, electronic or print, they have DOI, but otherwise the journals that were before 1990s, they don't have DOI unless they retrospectively give them the DOI. So once we do that, what we need to do is we may do some concept structure. We may do some kind of concept structure. So to do concept structure, what you need is, I think maybe we can have a look at the package tutorial. Maybe maybe let me see if there is some HTML version of the tutorial. Yeah, I think we can simply yeah, let me close this, and then we continue with the conceptual structure. The conceptual structure actually tells you the relationship between words, and it puts it in a cluster, or in a cluster kind of diagrams. It's kind of interesting analysis if you really want to have some kind of overview about your the contents of your literature. So for that, what you need keywords. You can do using a keyword. If you remember, keywords are DE. They are in terms of DE, you can use or title, or you can use abstract. So we can choose keyword now. The keywords. So for that, what you need is, let me call it concept structure, and then once you have concept structure, what you can is you call this concept structure function, and then the M is your data. The field is ID, and then for the field we define DE, and for the method we just leave it as MCA, or CA. We can also have a look what this concept structure actually mean. So I can simply copy this, and then I can have a look what the functions are about. Yeah, so this is creating and plotting conceptual structure map of scientific field. So this is creates a conceptual structure map of a scientific field performing correspondence analysis or multiple correspondence analysis, or these are really nitty-gritty details of citation. If you do bibliometric analysis, you may need to look at all these details, but since we are simply interested in having a brief overview of our records, because our interest is mainly on doing the text mining and the like, I'll simply do very quick analysis on this bibliometric analysis, just for your for my curiosity. It's not my field is not actually on. My interest is not actually on doing bibliometric analysis. So for the field, we can simply put keyword instead of going through the titles or abstract. We can just use the keywords, and the method. We can define the method. We can just define, let's say, CA, for example. So we can put it in a. And then once you define that, we can also say the mean degree of co-occurrence. So let me say 4, but we can also see what mean degree means. So the field can be all this. The field should be supplied with the text data, text data. The data should be like title or abstract or something. The method, as I said, it could be MCA, or this is also metric multidimensional scaling, but they really have a brief explanation in the package. You may also look at it. We don't need to do this. I think we can simply jump into the mean degree. This is an integer that indicates the minimum occurrence of terms. It's like how many times the term should appear in a document so that it would be included in the map, in the concept structure. I think that's what mean degree tells. And then we may say we may include stemming. I think stemming, we can define it as false or true. Stemming means is like cutting, pruning a word. Let's say if you, for example, COVID-19, for example, I don't know. If you say COVID-19 and if you do stemming, then this 19 will be stemmed, will be cut out, and COVID-19 and COVID, they will be considered as one word. If one article writes about COVID, if one of the term is COVID, the next one is COVID-19, then they will be considered as the same word. The same is like children. or child, let's say. So if you stem this REN, so these two terms will be considered as one. This is really important if you are doing real text mining, so stemming. If you especially want to only look at the root of the terms, then that could be very important. But for the time being, I will just leave stemming as false. And then label size. The label size is the size of the label in the map, because we are doing concept structure. They are going to be in a kind of dendrogram or a cluster map. So I can simply, depending on the size of my cluster, I can make it 10, the default. I can use the default, or maybe more. Maybe let me use 10, just the default. And the last important argument that you need is document is an integer. It indicates the number of documents per cluster. You know, how many times, if you want to do cluster, you know, if you do cluster analysis, you basically plot, you create a cluster, and that cluster is always more than 2, of course. I mean, one, you don't need to have one per cluster. So it should be more than 2. So the default is 2. If we ignore it, it could also be 2. But if we add, then you can also make it like 5 or 10 or. But this number is based on, you know, cluster analysis. You know, k-means clustering. I think I suspect behind the hood in this package, the guy is doing some cluster analysis. But I don't expect that, you know, the k-means clustering, like, you know, fine tuning to find the optimum number of cluster, that it should be 2 or 3 or 4 or 5. That should be defined by fine tuning. But for this case, we can simply use 2, like for one cluster, for one document. 2 documents per cluster, at least 2 documents. It's an integer that indicates the number of documents per cluster. Then once we do this, we can simply run it. So it will take, I suspect it will take a little bit of time. It's complaining now. Method is C. I must have forgotten something. Field equals D. Oh, okay, this seemed to be wrong. That's how I wrote it. So that should be like this, should be written field, not field. So, and then it should work now. So we run it, and it will take some time. Probably not much, but otherwise, if it's taking a long time, I can also pause the video and continue from where we stopped. Let me pause it. Welcome back. Now it's completed, so we may have a look at the concept structure. The concept structure, how they, you know, the keywords are clustered in this dendrogram. So this is probably, if I make it larger, I may have problem, but let me see if my laptop seems to be somehow having troubles with this analysis. Yeah, okay. If I make it larger, I will have a problem, but let me try once again. Yeah, anyway, this is kind of clustered into 2. I would say there is one cluster here and then another cluster here, but this one looks like more on education. Like, you know, COVID has changed mode of instruction. Many things in COVID, they were changed into online. So this part of the cluster seems to be talking about like education, media, and I mean like medical education. How is it changed into these online forms? So this seems to be in one part of the cluster, but there is also another big cluster talking more about. I'm afraid we cannot see this map. My memory seems to be struggling. My RAM. Maybe if I do this, probably we can have a little bit better look. Yeah. So anyway, we have some kind of two clusters, and one cluster seems to be dense. I think if we change the number of documents that we had, not the number of documents, is the one we mentioned somewhere here. Maybe if we change the label size, we may have a better outlook. Yeah, anyway, this is how it looks like. But if we do, clusters, they can either be in cluster map like this, or you can also present them in dendrogram. Again, for the dendrogram, it seems I'm also having a problem because of my R seems to be having a memory issue. But yeah, if it comes, we'll see it. Otherwise, we just pass to the next. But that's how you mainly do this this conceptual structure analysis. This concept structure. That's disappointing. Yeah. Let me maybe screenshot from one of the tutorials. Okay, here. So this is how the dendrogram will look like. It shows you this kind of dendrogram. So because we have only two clusters, it's really dense cluster because we have chosen many documents, and this is one part of the cluster, as I said, this education or something, and all the other COVID publications, it's putting it somewhere down here. It may not be that meaningful. And then probably the other one that might be more interesting is this analysis. Let me put it again. This one here, I will bring it. Yeah, this one is probably more interesting if you really want to have a look. So this is how it's creating. For example, in this case, it's creating how many clusters. There's one cluster here, which is, as I said, it's more on the education. How COVID probably has changed the mode of education. So it's changed into distance education. So it's somewhere here. This is one cluster, and there is another cluster which stand out lonely here. That's organization and administration, because COVID has changed lots of the way things are organized and managed. So this is one part of the cluster, and there is another one. Probably this is experiment. I mean, this is like researching on like environmental factors like cities, air pollution, nitrogen dioxide, and all these air pollution issues and its effect on I don't know, COVID infection or something. And then there is another part which probably may also fall into environmental factors, and that's on like temperature and humidity, all these UV ray and all these things they are kind of also relevant in COVID literature, because there is I'm not gonna into that details, but there was this UV and sunlight, and some countries with high sunlight and UV radiation, they are not very much affected, and those kind of stuff. So this part of the literature is concentrated down here, but all the other ones, all the genotypes and viral reaction or the cytokine are all concentrated in here, like the center of the cluster is somewhere here. Anyway, all the other ones, all the blue ones written here, they are concentrated here. So this kind of analysis may be relevant if you are looking at, especially if you are doing systematic review or something. You can quickly have a quick look of your literature, especially if the included studies, if you are the studies that are relevant for review or something. I like this cluster, so especially with the keyword, it might be something interesting, and you may want to look at. But this bibliometric analysis, there are also other functions, other popular functions that you do. Sankey plots, for example. Sankey plot is like relationship. One topic to the other. Maybe I can quickly Google and show you how Sankey plots look like. But it's called three fields plot. Three fields plot. Maybe Sankey plots. They're really interesting because it's like a Venn diagram, so you show the relationship of one term into the other. So probably I can have a picture. Not this one here. This is what I need. Yeah, these are the Sankey plots. These are called Sankey plots. It's mainly showing you the relationship of one term into the other. So maybe you can correlate the author name with keyword or journal. Then let's say you may correlate author with a journal. So that means which of the authors actually publish in which journals. So you can have an overview of a journal preference, let's say. Yeah, that's what you do with Sankey plots. I think with the Sankey plots, Massimo, the author of the package, he called it three fields plot, but the idea behind is Sankey plots. Sankey plots. That's Sankey plots. You can also do it in a different package. Yeah, you can also relate your your data frame, like three variables and how they look like. And the function for that, for doing Sankey plots, is you do three fields plot. Seems my R is having memory issue. This bibliometric analysis, it's taking much time. Okay, three fields plot. And then once you define that, what you need is data. That's COVID-19. The data that I already mentioned, and we define the fields. We just define the fields. What are the fields? These fields are, we define them, which field to relate. So let me create a concatenated list of author. Author is defined as AW. Oh my god, it's getting slow. Yeah, author and keyword, let's say. I'm running out of memory issues. Okay. That's keyword DE, and then we can define the source. That means the journal name, and that's all. Once you define this, you get your three fields plot or the Sankey plots. Let me check fields plot is written correctly. Three fields plot. Yeah, now it's correct. Now we can simply run it and expect that it will take some time. field A is not column name of inputs. Yeah, okay, this should be author AU. Then once we define that, then we can simply run it. But as I said, this may take some time. I will again pause the video and we'll come back in a minute. Welcome back. Our Sankey plot is completed now. We can open it here, but it's because the type of graph is a little bit large, so we need to open it in HTML viewer. So what we need is this HTML viewer in R. Then it will open, or you can also zoom, but I think the zoom function probably is not a good idea. But yeah, okay, it works actually. So this is how it looks like. So you have this guy. The moment you probably, I don't know. So I would go for the HTML viewer, but yeah, it's better to open it in HTML viewer. Let me see if it has opened it. Yes, already open here. Here. Oh my god, this is taking a long time. Okay. Oh yeah, here. Okay. So using two screens. That's the disadvantage of using two screens. Okay, so that's how the Sankey plot look like. It's really a nice plot. So you go into because it's also like interactive plot. So let's say if I am interested in chain, these are the author names, and here are the names of the journals, and these are the keywords. So you just click the name of the author, and it shows you the journals that this guy is publishing, and the keywords. These are actually the keywords, and these are the journals. So let's say, and then the size of this bar indicates the how prolific that keyword, author, or journal is in that particular topic. Let's say this journal is emerging microbes and infections. So if you click this, it shows you all. It activates them actually. They all activate these all keywords that are being published in this journal will appear. You can also start from here and then see. Yeah. So it's kind of interesting plot, probably useful, but yeah, you can also minimize it like this. Yeah, that's called Sankey plot, but it mainly shows you the relationship between like three different variables. That's why the guy called this plot into three fields plot. So you have the author name, the keywords, and the source or the journal. Yeah, that's one interesting plot from Massimo, the author of the package. I think it's better that we stop this bibliometric analysis today, and then we continue with author keyword co-occurrence or something in the next one, and then we will jump into text mining, and we'll do some real text analysis and do word clouds and network maps and the like. Thank you very much. I hope you find this very interesting. I found it very interesting and really applicable, especially if you are doing biomedical text analysis or maybe systematic review or something. You might be interested in looking at. It's not also difficult to learn. It's quite easy. You just all the functions they are already written, so you just need to take a quick tutorial and then you can reproduce and you can learn from it. Yeah, thank you. Having said this, thank you for watching, and you may subscribe to the channel. Thank you very much. Ciao.